Hello, I'm going to do this worksheet with you tonight. I hope it works out well. I do have a difficult time writing small here, but I wanted to get a lot of work in, so let's just see how this goes. If you have a printer, you can print this out and go along right on this handout, take a picture of it and submit it to Schoology. If you don't have a printer, do it on notebook paper, take a picture of that and submit it to Schoology. So this is factoring quadratics. These are called quadratic expressions because in every problem, the independent variable x is squared. That's the highest exponent. These are said to have a degree of 2. The highest exponent is 2. So, as you factor these quadratics, we're going to match the expression to the correct letter, to the factored form. So that's our goal here, is to match each number to a letter. Let's get started. Well, this isn't, okay. So in our first problem, we see the constant is 48, and the number in the middle we like to call b is 14. Let me just explain this for a moment. The number at the very end is called c, constant, and the coefficient in the middle is b, and then the coefficient in the very front is a. In all of these quadratics, there's no number seen in the front. That means it's just the invisible 1. So that's why this says factoring quadratics when a is 1, because all of these problems have invisible 1s in front of x. The leading coefficient is 1. So here we're looking for numbers that multiply to c and add to b, and then we put them in parentheses. All right, so number 1, x squared plus 14x plus 48. We need numbers that multiply to 48 that have a sum of 14. So what numbers will multiply to 48? We have 1 times 48. And we have 2 times 24. And we have 4 times 8. Not 4 times 8. 6 times 8 makes 48. One thing about factoring, and I don't really need to, but if you would like to have a calculator out to try different numbers, you can. It can be a helpful tool. Okay, so now we need to look at all of the sums of these numbers. 1 plus 48 makes 49. 2 plus 24 is 26. 6 plus 8 is 14. So 6 and 8 are the numbers we want to use. We're going to put those numbers in parentheses. X plus 6, x plus 8. It doesn't matter what order they're written in. Maybe it should be x plus 8, x plus 6. These are the same thing, and they're exactly equivalent to the problem we have. I'm just going to reiterate that for a moment. These are all the same. This is called standard form. And this is called factored form. But they really are the same expression, and like we practiced last week, if you were to FOIL either one of these binomials to do double distribution, first, outer, inner, last, you would get the problem we started with. That's what I mean by they're all the same. They're just written in different forms. So let's take a look. Our goal was to do matching here. Is that any of our numbers? X plus 6, x plus 8. Looks like it matches with K. There we go. All right, and if you have any questions as we go through, please just message me and or go to the video conference scheduled Wednesday, and I can answer your questions then. Let's continue. Number 2. In number 2, we want to multiply to 16 and add to 10. So what numbers will multiply to 16? 1 times 16, 2 times 8, and 4 times 4. Those will multiply to be 16. Let's figure out the sums. 1 plus 16 is 17, 2 plus 8 is 10, 4 plus 4 is 8. We were hoping to find numbers that add to 10. We did, 2 and 8. So those are our numbers. X plus 2, X plus 8. And again, that can be switched in the other order, and that's fine. Let's figure out which answer that matches with. X plus 2, X plus 8. I see it in letter E, right there. All right, very good. Let's continue on number 3. All right, in number 3, I wish I could call on you guys right now in the classroom, and I would just pick one of you and call on you, and you could give me numbers, maybe having so much fun. But I guess I'll do it by myself. What multiplies to 30 and adds to 14? 1 times 30, 5 times 6, 2 times 15, 3 times 10. Alright, I can't think of any other factors of 30. So add those, I get 31, 11, 17, and 13. Let me write that. Okay, none of these add to be 14, so I'm going to think more about what could multiply to be 30. Maybe I'll check in a calculator. Am I missing something? I am not. So, because I couldn't find two numbers that multiply to 30 and add to 14, this expression cannot be factored, which does happen. There's lots of quadratic expressions in the world that cannot be factored. So you'll see this on tests and in textbooks. It's problems you see frequently. Sometimes it just doesn't work. It can't be factored, making things even trickier. Let's see if that was an option in our matching. I see it. Number 3 matches with J, cannot be factored. Let's go on number 4. After this, all of the problems are more difficult because there are subtraction signs. So we need to multiply to positive 7 and add to negative 8. Okay. I'm going to make a little note here for you. There's little tricks that you pick up on the more you do these. When it comes to factoring, the more practice you do, the better you get. If the last number is positive, and I wish I could write smaller, but I can't. In the middle is negative. Both factors are going to be negative. I'm going to type that, you guys. Something just happened. Alright. Alright, so I ended up just typing this in here. So we have a negative here in the middle for B and a positive at the end. So when the last number C is positive and the middle number B is negative, both factors are negative. And the reason for this is because a negative times a negative will create a positive. And a subtraction sign in the expression means that at least one factor has to be negative. So we need to find two negative numbers that multiply to 7 and add together to be negative 8. We have negative 1 times negative 7. That's it. You know, 7's prime. So our only options are really 1 and 7. So negative 1 plus a negative 7 is negative 8. So our numbers are negative 1 and negative 7. We're just going to write them as subtraction signs. And there it is. Let's see which answer that matches with. X minus 1, x minus 7. Looks like it's going to match up with B. All right, very good. Let's continue. Number 5. We want to multiply to be 14, add to be negative 9. So we have negative 1 times negative 14, negative 2 times negative 7. So which one of those will have a sum of negative 9? Well, negative 1 plus negative 14 is negative 15. Negative 2 plus a negative 7 is negative 9. So we're at x minus 2, x minus 7. 2 and 7 will multiply to be 14, and negative 2 minus 7 will add to be negative 9. X minus 2, x minus 7. Letter D. Again, it doesn't matter what comes first, the 2 or the 7. Signs are the same, it matches. All right, number 6. We want to multiply to negative 60. See if I can zoom this. Yes. And add to negative 4. So this is a little bit different. If you look at number 5, the last value is positive. Here, the last value is negative and the middle value is negative. In those situations, the last number we call C. Try one more time. If C is negative ever, if the last value is negative every time, one of your factors is negative. And these are the hardest ones to figure out. These are going to take you the longest time. These are the ones that are going to stump you the most. If the last value C is negative, then one of your factors is negative. And the reason for that is a positive number times a negative number is negative. Let's try to figure it out. We need to figure out what multiplies to negative 60 and adds to negative 4. So we have negative 1 times 60, negative 2 times 30, negative 4 times 15, negative 6 times 10. And 12 and 5. Negative 5 times